Good day. My name is Anthony Henry, and today I will be showing you how plants change lipids into sugar through lipid metabolism. To start off, lipids are used for components of cell membranes, signaling, and even energy storage. So it's not necessarily a bad thing for plants to have, but when it has too much, it needs to get rid of it. Plants can change these excess lipids into sugar. This sugar, sucrose, is a carrier for energy to different parts of the plant. Throughout this presentation, I will also be showing you where this pathway consumes and makes energy. As an overview, lipid metabolism process starts off in the oil body where the hydrolysis takes place. Then the fatty acid goes into the glyoxysome for oxidation and continues into the glyoxylate cycle. The next step is going into the mitochondrion for the citric acid cycle and finally leaves the mitochondrion for the more oxidation and glycogenic pathway in the cytosol. The first step is triglyceride hydrolysis in oil body. Note that Ra, Rb, and Rc represents a 5-carbon chain. Triglyceride is combined with 3 waters, which is a carboxylation by lipase, which comes from the oil body membrane. Once this is completed, it becomes glycerol and the fatty acids. These are the fatty acids that will be transferred into the next step. Continuing from the previous step, the next step is beta oxidation of fatty acids in the glyoxysome. These fatty acids are combined with ATP, which means that it uses energy, and combined with coenzyme A to then form a new molecule. This molecule now uses FAD in the oxidation step to remove 2 hydrogen molecules. Then that new molecule combines with water and creates another molecule. That next molecule uses NAD, which is similar to FAD, also oxidizes the previous molecule and removes 2 hydrogen atoms. Once it reaches at the end of the cycle, it continues over and over again. However, the product that we were looking for is acetyl CoA, which goes into the third step. Within this step, there were at least 2 energy being used and 1 energy being consumed. The third step is the glyoxylate cycle in the glyoxysome. The, the glyoxylate cycle begins with the previous acetyl-CoA combining with water, which creates a citrate. The citrate is then goes through another process of aconitase, which then makes isocitrate, and then isocitrate becomes a glyoxylate combined with a more water and acetyl-CoA, making malate. Malate now goes through another oxidation process with NAD and takes away 2 hydrogen molecules. This then becomes oxaloacetate, and then the cycle repeats itself several times. However, during the third step, where isocitrate becomes glyoxylate, there's a byproduct called succinate, which is used for the fourth step. In this step, there was at least 1 energy being made in this cycle. Continue on to the fourth step, which is a citric acid cycle in the mitochondrion. Normally, it begins with the acetyl-CoA and then goes through citrate and then becomes then continues on with the whole process of this citric acid. But thanks to the previous step of the glyoxylate cycle, it skips ahead to where the succinate is and then becomes fruminate and malate. To begin from succinate to frumate, it then goes through dehydrogenasis with FAD, which is again just taking away 2 hydrogen atoms from succinate. It then becomes fruminate, and then fruminate adds water and then becomes malate. This process makes up about 1 energy. Coming up to the fifth step now, the malate exits out of the mitochondrion for oxidation. It oxidizes using NAD, and then NAD leaves with one of the hydrogen atoms, creating another energy for the plant to use later. It becomes oxalate and uses ATP, so it uses one energy to become carbon dioxide and a type of permanate. This all happens in the cytosol. It then goes through the glycogenic, glycogenic pathway, which then the permanate becomes fructose, and then the fructose becomes sucrose. To summarize, the steps of the lipid metabolism starts off with the triglycerides hydrolysis in of the oily body. The fatty acids then go into the glyoxysome for beta oxidation. This is where the first sign of ATP is being used, but also where two additional energy is being created. A product of the oxidation goes into the glyoxylate cycle, and where it then creates more energy, and then a byproduct called succinate goes into the citric acid cycle in the mitochondrion, where it bypasses most of the citric acid cycle and creates malate. The malate then goes for oxidation outside of the mitochondrion, where more energy is being created, but also it uses an ATP for it to go through the glycogenic pathway in the cytosol. This also creates CO2, but also pyruvate, which then changes into fructose and then the end product, sugar or sucrose. That's the end of the presentation. I hope that you learned something new about fatty acids changing into sugar within plants. Thank you for listening.